So today we're gonna be discussing some matrices properties, uh, mostly related to adjoint of matrix. So first of all, adjoint is like the transpose of the cofactor matrix. But we're not really bothered about that. We want to focus more on properties. So the first property of adjoint is that if you have A and you multiply it by adjoint A, it's gonna equal to the determinant A times the identity matrix. So if you know this one property, you can derive most of the other properties, and we'll be looking at the derivations also. So the next one is uh, adjoint AB is equivalent to adjoint B adjoint A. So proof. So we use this property over here. So we know that AB times adjoint AB is equal to determinant of AB times IN. Now we'll pre-multiply by adjoint A. So what we get is adjoint A into A, B into adjoint AB equals AB IN. So this thing from this property is just det A B adjoint AB equals det A det B IN. Determinant of AB can be split into det A and det B, and we can just cancel these two. Similarly, pre-multiply by adjoint B. So you get adjoint B into B into adjoint AB equals shit, I forgot to multiply here, pre-multiply. So you get adjoint A over here. So adjoint, since we have pre-multiplied by B, it's gonna be adjoint B adjoint A, and this is just mod B, det B, and these two cancel. So you have finally adjoint AB equals adjoint B times adjoint A. And the second important result is adjoint of CI, or let's just call it CA, where C is a constant, is equal to C power n minus 1 into A. So let's just hold on, I forgot the result, so let's just prove it. So basically what we do is multiply by CA on left hand side. So you get CA into adjoint CA. Now we use the first property, which is determinant of CA times IN. And we know that C is a constant, so when you remove it, it's gonna be C power n into det A into IN. So what we have is CA into adjoint of CA equals C power n into det A IN. So we can get this as that, and now we can just pre-multiply by adjoint A. So adjoint A times A into adjoint CA is equal to C power n minus 1 det A into In, and we know this thing is just equal to det A into In into adjoint CA is equal to C power n minus 1 A In. So we can cancel these two, and thus we obtain the result adjoint of CA is equal to C power n minus 1 into, hold on, I think we are missing something. Yup, I completely forgot to pre-multiply by adjoint A. So when we multiply by adjoint A, we gotta pre-multiply by adjoint A when over here. But since this is just In, it really doesn't matter if I pre-multiply or post-multiply. So you get adjoint A. So that's how we get this result. Adjoint CA is C power n minus 1 adjoint A. And the next result I want to discuss is what is determinant of adjoint A. And this result is det A power n minus 1. So how we get this is, we first use the fact that A times adjoint A is equal to det A power det A into In, and now we just take mod on both sides. So determinant on both sides. So since the determinant is distributing, you can take det A and det adjoint A is equal to, and here det A is a constant, so when you remove it you get the power n. So det A power n into determinant of I is just gonna be 1, so I won't write it. So that's how you get adjoint determinant adjoint A is det A power n minus 1. And the other important result is, let's just take it up over here. Okay, now let's just take a fresh page. So the next result is adjoint A, and we want to prove that this is equivalent to if I'm not wrong, it's power n minus 2 A. So we'll prove this. So what we do first is, we do the same thing as before. We know that adjoint, let's consider this as some B matrix. So if this is some B matrix, then we know that B adjoint B is equal to det B times In. So we'll be using the same concept. So here adjoint A times adjoint of adjoint A, which is B adjoint B, which is det B adjoint A times In. And now what we do is, so now we know that the determinant of adjoint A from the previous result is just det A power n minus 1 into In. So on LHS, what we do is we'll pre-multiply by A. So A adjoint A into adjoint A is equal to A times det A power n minus 1. So now what we know this result is just det A power, and we get adjoint A is equal to A into n minus 1. Now we just divide by this det A, so that's how we get adjoint A is equal to A power n minus 2 det A power n minus 2 into A, and our final result will be determinant of this. So adjoint A is equal to A power n minus 1 whole square det A. So proof for this is gonna be you have to remember the previous result. That's why I really don't like matrices and determinants. So basically, let's just take mod of this. So mod of this is basically mod A, det A power n minus 2 A, and distribute the determinant. We get, since this is a constant, you can actually take it out. You don't distribute it. So you get det A power n minus 2 and whole power n times det A, which is basically det A power n into n minus 2 plus 1, which is det A n square minus 2n plus 1, which is det A n minus 1 whole square. And the final result is, what if we have to find adjoint many times. So basically, if you didn't notice it, let me just show it to you. If you have adjoint void written once, it's whole power 1, and if you have the adjoint void written twice, you have whole power 2. Similarly, if you have n times adjoint, then this is just det A power n minus 1 power n. Just remember this result. And finally, let's discuss this question. The question basically gives you like A as a matrix. It has a bunch of quadratics and even y terms, z. It's super ugly. In fact, when I saw this, I just gave up. But it turns out you just have to read the question. So after this, they've given you that det A value is equal to 3, and they've defined a function f of x as the trace of B inverse. So first of all, if you look at A and see the trace of this, it's gonna be only containing x. It won't contain any other y or z. So that should already like ease your mind a little bit. So, and they've defined B as adjoint A, then global maximum of f of x. So first thing is, you want to extract information from this. So they've given you B as adjoint A. This is where I really struggle in extracting information. So basically, from the properties that we learned before, we know that if you just multiply A, you get adjoint A times A, and this is just standard result into I. Since this is a 3 by 3, even B is gonna be a 3 by 3, so this is gonna be I3. So from this, what you understood is BA is equal to det A times I. I won't be writing 3 anymore. So if I get this down, we get B by A into A equals I. We know that this is similar to A inverse or A inverse A equals I. So thus we find out that A inverse is basically B by det A. So we can say that B is A inverse into det A. So they've given us the value of det A as 3. So let's just substitute it. B is A inverse times 3. Right, so now what we do is they've also asked us to find the trace of B inverse. So from this we know that B inverse equals I, but B is already A inverse into 3 into B inverse equals I. So basically B inverse is equal to A by 3. So now what we do is we can just find f of x. So from this, f of x is trace is basically sum of the I terms. So it's gonna be 1/3 of x cubed plus 1 minus 6x squared plus 2 plus 9x plus 6. And they want us to find the global maximum. So find f prime x. So this is basically 3x square minus 12x plus 9, which is basically x square minus 4x plus 3, x minus 3 into x. So this is gonna be x minus 3 into x plus minus 1. And they've asked, so we know that this is gonna be upward facing parabola 3 1. So here, so this is gonna be a minimum and this is gonna be a maximum, and they've asked us to find the maximum of f of x in 0 to 6. So basically let's plug in the values of 0, 1 and 6 and see what the maximum will be. It is important to plug in 6 also, because it could always be something like 0, 1, 3, 6. It could be something like this, and maybe it attains a minimum, but it kind of skyrockets. So it's important to plug in the value of 6 also. So, but we don't have to plug in 0. And now what? So let's just find f of 1. F of 1 is 1/3 of, so you get 2 minus 6 plus 2 plus 9 plus 6. So you get 4 13 by 3, and f of 6 is 1/3 of you get 6 cube. 6 cube is 6 into 36 plus 1 minus, oh okay 6. Okay, these two just cancel out. when you plug in 6. So you just get 1 plus 2 plus 9 times 6 plus 6. Oh yeah, this is like a much bigger value. So the global maximum is just gonna be 1 plus 3 into 12, which is basically 36, 37. That's the answer.